Myself, Anusha, and my teammates are N.Sravya Shree and K.Eshwara Valli. Our topic for this assignment was TensorFlow Probability. Have you ever wondered how we can represent uncertainty in real world applications? In machine learning and statistics, probability distributions help us describe different possible outcomes. TensorFlow Probability is a library built on top of TensorFlow that is designed for probabilistic reasoning and statistical analysis. It provides tools for building and training probabilistic models, performing uncertainty estimation. Now we will see the key features of TensorFlow Probability. The first one, probability distributions. TensorFlow probability provides a wide range of probability distributions like normal, Bernoulli, Poisson that can be used for statistical modeling and deep learning applications. These distributions support batch operations and transformations. Secondly, probabilistic layers and neural networks. TFP includes layers that incorporate uncertainty, such as Bayesian neural networks, which help to quantify uncertainty in predictions. The third one is Bayesian inference and probabilistic modeling. TensorFlow probability supports invariational inference, Monte Carlo simulations, and expectation maximization methods for Bayesian learning. Fourth one, statistical tools and functions. TFP functions for computing expected values, entropy, and sampling methods. It also supports kernel density estimation and hypothesis testing. And lastly, integration with TensorFlow. TFP can be seamlessly used within TensorFlow's computational graph for probabilistic deep learning.
Demonstration of codes with explanation. First, we need to install TensorFlow and TensorFlow Probability by pip install TensorFlow Probability in command prompt. TFP is imported for working with probabilistic models, and TF is imported since TFP works on the top of TensorFlow by the definition. And TFD is an alias that makes it easier to access distributions. TFD. In this code, we have created a normal distribution, which is one of the most common probability distributions. It is widely used because many natural phenomena like heights and test scores follows this pattern. In first line, normal dist is equals to TFD dot normal, log is equals to 0, and scale equals to 1, which means a normal distribution with mean equals to 0 and standard deviation is equals to 1. And samples is equals to normal dist dot sample 5, which generates the 5 random samples from the normal distribution. Sample dot numpy converts the TensorFlow to numpy array for easy reading. The output will be different every time you run the code since sampling is random. This means the distribution follows a bent curve centered at 0 with value spread according to the standard deviation of 1. The second code, it represents a histogram with 5 bars, each representing one of the sample values. If we increase the sample size to 10,000, the histogram will have many bins, creating a smooth bent curve. This histogram shows the most values are clustered around the mean of 0, with fewer values appearing as we move away. This bend shape is the key feature of the normal distribution.
To sum it up, TensorFlow probability makes it easier to handle probability distributions for machine learning and statistical analysis. Whether you need to model uncertainty, generate random values, or analyze probabilistic data, TFP provides powerful tools to help you. It is widely used in Bayesian modeling, deep learning, and generative AI applications. Thank you.